Hi everyone, it's Miss Fendel, and today we're going to talk about 3.2, graphing systems of linear equations and inequalities. So the difference between 3.2 and 3.1 is now we're just going to graph systems. Okay, so go ahead and turn to page 3 in your packet, and your first example should look like this. So determine the solution for y equals 3x plus 4 and y equals x plus 2. So I notice here that these are both equations and not inequalities. So because they're both equations and not inequalities, I know that my answer is actually only going to be 1 point. And it's going to be the point where these two equations cross. So all I'm going to do is graph these two lines on the same graph and see where they connect. So if I look at my first equation, I know that plus 4 is my y-intercept, so I start and make a dot right on the positive 4 y-axis. Then I know my slope is 3, positive 3, so I'm going to start from where I began on plus 4, go up 3 and over 1, make a dot, and I can go on the other side, backwards 1, down 3, make a dot, backwards 1, down 3, make a dot, and so on. Then I can connect all my dots to make a line. Then I go to my second graph. My intercept is plus 2, so positive 2 is where I start. I know my slope is just x, which means an imaginary 1, so it's up 1 over 1 from where I started with, and I just make a bunch of dots. Then I connect my line, arrows on the end, and I look for the point where they crossed. Now you can see on your graph and on mine that the point that they both had exactly the same point was right here, which is at negative 1, positive 1. So my solution is negative 1, positive 1. This is my final answer. If I wanted to, I could also put this into my graphing calculator, plug both of them into different y equals, graph, and then hit my second trace and intersect that you guys know how to do already, and you'd get negative 1, 1 as well. Okay, so now let's look at example 2. Example 2 says to graph and find one point that lies in the solution set. So if I see I have two inequalities here, one is y is less than negative x plus 1, and the second one is y is less than or equal to 2x plus 3. So I know that I look at my rules, this is the two that I'm using. So both of them I'll be shading below, but one will be a dotted line and one will be a solid line. So first I'm going to plot my y is less than negative x plus 1. I know that my positive 1 is where I start my y-intercept, so I make a dot on positive 1. And then it's a negative x, meaning negative 1, so I'm going to go, instead of up 1 and over 1, I'm going to go down 1 over 1, down 1 over 1. And I can make as many of these as I need to or want to. The next thing I'm going to do is make sure I either do a solid or a shade or a dashed line, I know this is y is strictly less than, so it's not actually including the line. So I'm going to draw a dashed line. It still has arrows on the end. Then I need to think about shading. So it says y is less than. So I'm going to go back to my original y-intercept and think of any value that's less than that. So I know it's going to go downwards. So I'm going to shade in red all that lies for this portion of the solution. The difference is now I have to graph another inequality, and my solution is only going to be where both of those are shaded. So let's look at y is less than or equal to 2x plus 3. I start at positive 3. My slope is 2x, so up 2 over 1. Up 2 over 1. I'm going to make some over 1 down 2, over 1 down 2, over 1 down 2. I also know that this is a or equal to. It is not going to be a dotted line. It's actually going to be solid because it is also equal to the line. But it still says less than. So now I'm going to go back to my original y-intercept. It needs to be less than. So again, I'm going to shade downward. So all of this in the blue is what's the solution set for that. Now I have to actually think about my solution set here is only going to be where there's blue and red. So if you can see, this section of the graph is my actual solution set. And I would maybe make an arrow and point to that and do my SS for solution set. So the only green shaded is the only place where it's the actual answer. So I also have to remember that it says also on my directions to find one point that lies in the solution set. So really you can choose any point in the green as long as you can tell me what the exact point is. So if I wanted to pick, for example, this point right here, I know that's 1, -2, and that's a solution. So I could say 1, -2 is a point in the solution set. And I'm done. So let's move to the next. Example 3 is the same thing. It says graph and find one point that lies in the solution set. I see one of my inequalities is already in slope-intercept form, but this one, however, the first one is not. So I first need to put this into slope-intercept form. I need to have y by itself, which is actually really easy here because all I need to do is add 6x to both sides so that y is by itself, giving me my new inequality of y is less than 6x plus 3. So I'm going to just graph both of these. On my first graph, I see positive 3, so I start at positive 3. My slope is 6x, so it's up 6 over 1. So 1, 2, 3, 4, 5, 6 over 1. 3, 4, 5, 6, down 1. And then I just need to decide if it's going to be a solid or a dashed. There's no or equal to underneath my inequality, so it's going to be dashed. Now I want to graph the shaded portion. So I know that it is y is less than, so again I go back to my y-intercept, positive 3. It's less than, so it's going to go down, and I'm going to shade everything on this side. Now I need to graph my second inequality. Has an intercept of -2, so I draw my -2 on the y-axis, and my slope is positive 1, so it's just up 1 over 1, as many dots as you want. And again, I have to ask myself, is this going to be a solid or a shaded, solid or a dashed line? And it's strictly greater than, so it's going to be a dashed line. Arrows on the ends. Now I need to decide where I'm going to shade. This one says y is greater than the line, so I'm going to find my y-intercept at -2, and I'm going to think of anything greater than, so I'm going to go up. So I'm going to shade above this line. Now now again, I can only have a solution set that includes both green and blue. So if I find my portion that has both, it's actually just right here. And I need to find one point that lies in the solution set. Again, you can choose whatever you want. I'm going to choose an easy one. That's 1, 1. So here's my solution set. And 1, 1 is a point in the solution set. And I'm done. So you have a few examples that you need to work through yourself. At the end of the packet, there's also a way to solve without graphing. So this is asking you to solve on your calculator. So all I'm going to have you do is write down the steps for you to solve on your calculator if you were going to, and how to enter that in. I'm going to show you on mine. So here's the steps. First, you always need to make sure that your inequalities or your equations are in slope-intercept form. So change to slope-intercept form. Like you can see here, neither of these are in slope-intercept, so I'm going to have to change them. So let's do that. This one, I need to subtract 2x. And this one, I'm going to need to subtract 2x and divide by a negative. So let's do this one right here. If I subtract 2x on both sides, you'll get negative 3 minus 2x. Or, if you want to switch those around, negative 2x minus 3. The second one, I need to also subtract 2x. But then I'm still left with this negative y, so I need to divide by negative 1, because here's an imaginary 1. I need to divide everything by negative 1 on this side. And when I divide by a negative number, when solving an inequality, my sign changes. So now I have y is greater than or equal to, switched, negative 1 divided by negative 1 is positive 1. Negative 2 divided by negative 1 is positive 2x. And again, I can switch this if I want to say 2x plus 1, so that I can see my slope and my intercept. Then I'm going to go to my calculator, step 2, plug both into y1 and y2. So you're going to hit y equals, you're going to plug both of these inequalities into y1 and y2. And then the last thing you want to do is change the line to be shaded. So you'll see what I mean by that. So I'm going to show you how to use your graphing calculator to plug both of these in. So if you go to your graphing calculator, here's mine. I'm going to put both of these in. So I'm going to go to y equals, and then I'm going to put in both of my equations. So I have negative 2x minus 3 negative 2x minus 3, and I have 2x plus 1. 2x plus 1. The only difference is if I want to have an inequality, I can go over to this area over here on both of them, bring it all the way over so that it's blinking, and I can push enter and I can change from a line to be shaded. So if you see here, this says y is less than. So I'm going to hit enter, enter. This is greater than. If you can see, the shading is above. You can also see in the graph over here. So I want to hit it one more time to be less than. On this one, I do want it to be greater than the second one. So I go down to this one, the second y2, push enter. I don't want this one, push enter. That is greater than, as you can see. And then you hit graph, and it'll shade for you. So here's my two lines. And you can see that the dual shaded region is right here. And you can pick any points from there.